So first I'm going to explain you how to name alkanes, alkanes and alkenes. What we need to do first is to recognize our longest carbon chain, which one in this case or in this one. It will be in this one all of these like triangles, and in this one that it is like the first one that the teacher teach us, it will be this one. We could also go like for this little branch instead of the last number, like this. We could go like this or like this, but in chemistry we prefer to use the straight one. So the next step we need to do is to name the different branches that are in our carbon chain that are connected. These ones are like the carbons that are not part, that they don't give more carbons to our longest carbon chain, but they are part of it. They are like connected. Like for example, this one is a branch, and this one it is the methyl. It also exists the ethyl, which one it will be like this from 2 carbons, the propyl, which one it will be from 3, and the butyl, which one it will be from 4, like this, and they will be all connected to our longest carbon chain. Now what we need to do, once we have already recognized which ones are the branches that we have in our problem, in our carbon chain, we need to write them in an alphabetical order. So to name it, we need to write them in an alphabetical order. Like in this example, we've got the 7-methyl. We have to write in which carbon we have our branch, but how are we going to know in which carbon we are going to write it? Well, as you can see in this one it is a alkane with ENE because it has a double bond. The alkane with ANE, it only has single bonds, it doesn't have double bonds. And the alkene, the one with YNE, it has triple bonds, which one it is like 3 lines. Let me open my marker. It will be like this, the triple bond, the double bond like this, and the normal ones are the single bonds like this one right here. So in this problem, this is another way to represent like the carbon chains. We've got right here a double bond, but right here we don't have one. We also have one right here and one right here. So because of we have one right here and we can start from here, this one it is the closest from the number 1 if we count from left to right. So it will be 1, we have this one, 2, 3, then we have another one, 4, 5, we have another one, 6, 7 and 8. And if we start from the right to the left, it will not be the same, like 1 and we don't have none, 2 we don't have, 3 we have one, 4 we have one, no, 4 we don't have one, 5 we have one, 6 we don't have, and 7 we have one. So what we need to do is to look at our problem and see for in which side we have a closer double bond or a closer branch, as it could be a methyl, ethyl, propyl or butyl. Now we can like start naming our problem. In this one it will be 7-methyl because in this number 7, in the carbon 7, we have a methyl, which one it is represented with a line in this like system. In this one it will be just like the line and the CH3. In this one it is just the line. the 7-methyl, and the 1 and the 3.5 1.3.5 octadiene with E and no octadiene with Y and E, because we have triple bonds right here. It is octadiene because our carbon chain, it is made of 8 carbons. We have D, wait, let me erase this right here. So we have D or 3, like this it will be 3DN because we have 3 triple bonds. But if we only have 2, it will be D triple bonds. D from 2 as the numbers. Oh. And that's the things that change, that if we have a alkane, we don't have double bonds or triple bonds, we just have single bonds. And when we have alkanes with E and E, we have double bonds. It could be 1, 2, 3, doesn't matter. But if we have triple bonds, we are going to have the termination with Y and E. So that's how you name them. So this is how I will represent a 1-butyl, 2.2 diethyl, a 3-propyl, and cyclobutane, and a cyclobutane. I made this figure by using different tees. That is something we use to play golf. We put the ball in this part of the tee and we use it for some shots. These are made from wool, this is from plastic, these two with lines, and this is a piece of Lego. So this is how I represented the 5-butyl, 2.2 3-propyl, the 3-ethyl, 1-methyl, and here's the double bond, the 1.3, that's the 1.3 cyclopentadiene. So as the last one, I made this also with the tees, with the same materials, with wool and plastic. So I don't know if you appreciate it very well, but I need to record it like this because if I hold it like the other ones, it was going to break. So this is how I represented the 4-cyclohexyl, then the 3-cyclopropyl, then the 1.2 diethyl, this one and this one, then the 5-methyl, this one, then the 6-propyl, this one right here, and the 1-cyclohexene, this one is the triple bond. It is very little because if not, I was not going to be able to fit it in there.